Yes, I welcome you all for the automata theory class. So today I'll be taking with the continued part of the fourth module. So some of the short theorems you are having for the context free languages. Okay. So if you are having a two languages are context free, then the union of these also denote the context free. How you are taking out? As you know in the grammar, you are having a variable terminal production starting symbol. It is accepted by the language 1, and similarly variable terminal production accepted by language 2. So if you are having a two variables are different disjoint, then if you take a union, then what happens? L1 and L2 will be union. Okay, then what happens? The third grammar will be of combination of variable 1, 2, and starting symbol will become new symbol, that is third S3. Okay, and terminals will be combination of both first grammar, second grammar. Then production is new one, and starting symbol become your S3 except by the language L3. And S3 is the starting symbol of grammar 3, and S3 does not belongs to either grammar 1 and grammar 2. It is totally new symbol belongs to grammar 3. And production 3 is what combination of production 1, 2, and you are having what S3 implies S1 or S2. Okay, this grammar you can represent. Therefore G3 is what context free grammar. Hence L3 is a context free language. Suppose if you are having two context free language, then if you take a union of those two also become a context free language. Okay, next. If you take a two languages context free, then concatenation also become a context free. How? So as already seen in the proof, suppose you are having grammar 1 with variable terminal production, grammar 2 with variable terminal production. Okay, if variables are disjoint, but if you take the concatenation, then a grammar 3 will be generated, which is having a new starting symbol. Okay, so if you are having in this case S3 will be new starting symbol, does not belongs to either grammar 1 or grammar 2, but concatenation what happens? Starting symbol will become what? S3 implies S1 dot S2. S1 is the starting symbol of first grammar, S2 is the starting symbol of second grammar. Hence G3 will become what? Context free grammar. Hence the language accepted this is also a context free language. Hence if you take a concatenation of two languages of context free, then again the new language whatever you generated is again a context free language. Okay, next, if L1 is a context free language, then closure operation is also a context free language. Okay, so here what happens? S1 implies S1 or epsilon will become your context free grammar. Then hence L1 star is also a context free language. If you take a context free language, then if you take a closure operation of this, it is also a context free language. Okay, next thing we will see with if you take two languages context free, then intersection of them is not a context free grammar. Okay, so how? Because if you take a two grammars a raised to n, b raised to c raised to m, a raised to n, b raised to m, so if you write the grammar, then the resulting production is not a context free. Hence intersection of two context free language is not a context free language. Okay, next, if you take a complement of context free language, then again it is not a context free language. How? Suppose the resulting value whatever you generate for the applying De Morgan's law, that will not become a context free. Hence if you take a complement of context free language, then it is not a context free. Only for union, concatenation, closure operation it is context free, but intersection and complement will not become a context free language. So see, there are the five simple theorems you are having on the context free language. Okay, so go through this video. If you have any doubts, we will discuss in the interaction class. Okay, thank you.